Now that you've had the basics regarding chemical equations, we want to learn how to balance them properly. And by balancing them, we're talking about putting in proper coefficients in front of each element or compound. So there are some steps that I'm going to show you that you're going to use each time, and it's not necessarily mean that you have to go through these steps every time and write them down, but you will at least go through them mentally when you're balancing. So the first thing we want to do is write out the unbalanced equation. Now that means writing proper chemical compounds, proper formulas in their proper places, meaning if they're reactants, putting them on the left side, and if they're products, putting them on the right side. Then you always want to count the atoms on each side. You're going to add in coefficients to make the numbers equal. And you're essentially going to multiply by these coefficients. You always multiply coefficient times the subscript. That equals the number of atoms. It's a lot like using the distributive property in math. If possible, you need to reduce the coefficients, meaning if you end up with a 2 and a 4, you're going to reduce those to a 1 and a 2, because we always want to see the lowest possible ratio if we can. And then you want to double check them after you're all done, or after you think you're done, just to make sure you've got it balanced properly. Some hints, and as you go through, you're going to find that each equation is done differently. So these are just some hints that might help you. Balance one element at a time. Get one element balanced, then go on to another element. Sometimes it's hard if you're trying to do 2 or 3. If you're trying to cut corners, that doesn't always work. Make sure even when you balance one element that you update all the atom counts after adding a coefficient, because putting a coefficient in front of a compound will affect more than one element. And if you have an element that appears more than once in one side, meaning you have, for example, hydrogen in 2 compounds on the same side, do that one last. Put that one aside and save that one for last, because that'll be your more difficult one. And the more of these you do, the more you're going to be able to recognize the polyatomic ions that we started learning about last chapter. And you see the example down there, the SO4 ion, that's the sulfate ion. If you can recognize that as an SO4 ion, as a sulfate ion, then instead of balancing sulfur and oxygen, you can just balance the SO4 ion. You can combine steps. This is something that you're not going to be able to do at first. When you first start balancing equations, I always recommend you balance it element by element. Then as you get more comfortable with balancing after a few days and you can recognize these ions, then go ahead and balance them as the ions. It'll just make it a little bit simpler. All right, so let's take a look at this example here. You have hydrogen and oxygen combining to form water. What we want you to do before you begin balancing this is to make a table at the beginning. And by making a table, you're going to make 2 sides. This is the reactant side and this is the product side. So the reactant side here and the product side's over here. And in the middle, you can put your elements. I have hydrogen and I have oxygen in the reaction. On the reactant side, I have 2 hydrogens and I have 2 oxygens. So that's why I have those 2's down here. On the product side, I have 2 hydrogens but only 1 oxygen. So that's why I have the 2 and the 1 here. For an equation to be completely balanced, we have to have the same number of the same type of element on both sides. The elements don't need to be equal. I don't necessarily need to have the same number of hydrogens as I do oxygens, but the oxygens need to be equal on both sides. And so in this case, the hydrogen's already balanced, so I'm just going to leave that one. But the oxygen is unbalanced. I started out with 2 oxygen atoms, and I only ended up with 1 oxygen atom. Well, that can't happen. I can't lose an oxygen. So in order to balance it, I need to get 2 oxygen atoms on the product side. So what do we need to multiply by 1 to get 2? Well, that's 2, of course. So what I'm going to do is I'm going to put a 2 out in front of the water. I can only put coefficients in front. I can't put them in the middle of a compound. So I'm going to put the 2 in front. Now that's going to give me 2 oxygens because essentially I'm multiplying this coefficient times the subscript. So 2 times 1 is going to give me 2. But notice it's also going to change the hydrogen because I've got this 2 out front. We're going to multiply that by the subscript, and that's going to give me 4 hydrogen. So even though I balanced the oxygen, now my hydrogen's unbalanced, and that's okay because this is something where you're going to go back and forth between the reactant side and the product side. So you might balance one element and then another element's going to become unbalanced. That's all right. So we've got our oxygen balanced now with the 2, but now my hydrogen's unbalanced. I've got 4 hydrogens on the product side and only 2 on the reactant side. So I got to get 4 hydrogen atoms on the reactant side. So what can I put in front of the H2 to multiply by 2 to get 4? Well, it's going to be another 2. So I'm going to put a 2 in front there. That's going to change my hydrogen to 4 on both sides. So now my hydrogen's balanced and my oxygen's balanced. So this equation is balanced. So I've got 2 hydrogen molecules combining with 1 oxygen molecule to produce 2 water molecules. Anytime hydrogen and oxygen react, it is always in a 2-to-1 ratio. I always have to have 2 hydrogen atoms or 2 hydrogen molecules react with 1 oxygen molecule. If there's only 1 hydrogen molecule, the reaction will not take place. So that's how we balance equations. You can only balance them by putting coefficients in front of the compound or the molecule. You cannot change the subscripts. You can never change subscripts because if you change subscripts, then you're changing the formula. You're changing the compound, and it's not what it is. So the answer that we're looking for in the balanced equation is the equation itself. The table is just to help you keep track of atoms. That's not part of your answer. That's just done off to the side. So let's look at another example. And this is an example now where it's given to you in written form. So not only do you have to balance it, but first you have to write down the proper chemical formulas. So we have aluminum and copper 2 chloride react to form copper and aluminum chloride. So the first thing we need to do is write down the proper formulas for each. So we have aluminum reacting with copper 2 chloride, CuCl2, to form copper and aluminum chloride, AlCl3. So I have 3 elements. I have aluminum, I have copper, and I have chloride, or chlorine, in my reaction. So to start out with, I'm going to put down how many of each I have. On the aluminum, I have 1 aluminum on both sides. I have 1 copper on both sides. So that's good. But when I get to chlorine, I have 2 chlorine on the reactant side because of this 2 right here. And I have 3 chlorine on the product side because of this 3 right here. Now, why do I have 3 chlorine here? Because aluminum is a +3 charge and the chloride ion's a -1. So I have to have 3 chloride ions to balance out this aluminum. But the copper is a +2 charge, so I only need 2 chloride ions to balance out the copper. So that's why the subscripts are different. So what we're going to do here, chlorine's the only one that's unbalanced. I have a 2 and a 3. Well, there's no whole number I can really multiply by 2 to get 3. So we're going to look for a common denominator, which between 2 and 3 is 6. So I'm going to try to get 6 chlorines on each side of the reaction. So in order to get 6 chlorines on the reactant side, I need to multiply this 2 by 3. So I'm going to put a 3 out in front here. Now that 3 is going to change my copper to 3. And it's going to change my chlorine to 6. No big deal. Because now I'm going to go back over to the product side. And I have 6 chlorine over here. I only have 3 over here, so what can I multiply by 3 to get 6? Well, I can multiply it by 2. So I'm going to put a 2 in front of the AlCl3. Now that's going to change my aluminum to 2, but it's going to change my chlorine to 6. So my goal was to balance the chlorine atoms, to get 6 of them on each side, because that's a common denominator between 2 and 3. And so that's what we did. But in the process of balancing the chlorine atoms, I've unbalanced the copper and the aluminum. But you know what? That's going to be a pretty easy fix, because I have single aluminum and copper atoms. So for the aluminum, I have 2 on the reactant side. I only had 1 on the, or I'm sorry, 2 on the product side. I only had 1 on the reactant side. So I can simply put a 2 out in front of that aluminum. And for the copper over here on the product side, as you can probably see, I'm just simply going to put a 3 in front of that one. And that's going to change that to a 3. So when I'm all said and done, we're going to need a 2 in front of the aluminum, a 3 in front of the copper chloride, a 3 in front of the copper, and a 2 in front of the aluminum chloride. So that I have 2 aluminum atoms reacting with 3 molecules of copper 2 chloride to produce 3 copper atoms and 2 units of aluminum chloride. A 2 to 3 to 3 to 2 ratio. That's what this reaction needs to occur in. I need 2 aluminum atoms to react with 3 copper chloride units at all times. If I don't have that ratio, the reaction will not take place. So let's quickly go back here to the beginning when we wrote down the proper equation. Notice chlorine was the only element that was not balanced. Aluminum and copper were already balanced. But in the process of balancing the chlorine, I had to unbalance the copper and the aluminum in order to get the entire reaction balanced. And that's okay, because it's a step-by-step process. And as a reminder, you have to have proper formulas written in order to get it balanced properly, because if we didn't have the proper formulas for copper chloride and aluminum chloride, we would not have gotten the proper balancing to take place either.